Welcome to the presentation of our Discrete Math course. I am Vushil Bhavsar, representing my group throughout this project presentation on labor cost estimator. So let's begin with a question. What is estimation? Estimation is a very common doing that one makes all the time, be it a farmer sowing its farm at the beginning of a season, or a doctor in diagnosing a patient's disease, or a stockbroker in investing money in the stocks. Every estimation is based on some particular conditions or variables that affect the estimation. Such estimations can be very helpful in addressing some problems. Now let's move on to some problems that are addressed by our project. Be it an institution or a small vending store, one may come across a dilemma of estimating labor for their employees. So there hops in our labor cost estimator to help out, which estimates the labor for any post by taking two variables. One is time that a person works, and second is money that is paid to the person using some simple matrices. The main idea of this project is to use an algorithm simply using metric identities that can perform this process of estimation for the user based on a training set provided by the user. A training set consists of some information prior to the estimation of the cost in the form of labor time and labor cost. For better understanding of the algorithm, let's take an example. Here is a typical training case consisting of work time and labor cost of a worker, which we will use in our algorithm to estimate the labor cost. First, we will start by arranging the training values in two matrices, A with the hours worked and B with the wages paid. Further in the algorithm comes the hypothesis matrix. The size of the hypothesis matrix is based on the power of the estimation, which is to be provided by the user. For simplicity, let us assume a quadratic polynomial. Based on the power of estimation, we have to rearrange the variable matrix A. As we have decided the power of estimation to be quadratic, we have to arrange the variable matrix A into a 5x3 matrix by making the values as 1, A and A square. Further using the normal equation, we will be able to find the H matrix. Substituting the values of hypothesis matrix in the quadratic equation, we get the hypothesis equation, which is key in finding the estimation cost. This is the hypothesis curve representing the labor cost estimation over a range of variable time. By putting the value of x, that is the time of labor, we can get the labor cost. Here, we can choose labor time as 3 hours and we get 366 rupees as the labor cost. Now, talking about some real life applications of the project. Stating some of the many uses, an estate official can get a great benefit by predicting the cost of the houses based on different variables and can estimate the price to sell the area accordingly. Also, stockbroker can estimate the price of stocks on the basis of the previous data and can estimate the increment or decrement in the price of stocks that one might choose to invest on. Here are the references that we have used throughout our project. A paper by Randal J. Barnes on matrix differentiation and a paper posted on advanced.washington.edu on derivation of normal equation were of a great help during our project. We all are very thankful to Professor Gupta for teaching us the basic of discrete mathematics and making us capable to do this project. Thank you so much for your attention. Hope you liked our presentation. All the links related to the project are listed in the description box. Also check out our website for more info.